In this video, I want to continue with problems 55 through 59. And these are more examples of evaluating limits algebraically. We've seen that we can use direct substitution, which is just to plug in the x value into the expression. If it works, that's your limit. We've also used the technique of factoring and canceling. And in 55 and 57, we're going to use a strategy called rationalizing. So with number 55, we have the limit as x approaches 4 of the square root of x plus 5 minus 3 over x minus 4. Now you can try the other methods that you've learned. If you try to plug in x equals 4 here, you're going to end up with 0 over 0, so that doesn't work. There's nothing to factor out here. But the radical is a clue that we can use the rationalizing process. And so what we want to do is to multiply top and bottom by the conjugate of the radical expression. And that would be square root of x plus 5 plus 3. And again, obviously we have to multiply top and bottom by that. Now to evaluate this, the numerator is a difference of two squares, so we're just going to square the first term minus square the second term. So we have the limit as x approaches 4 of x plus 5 minus 9 over x minus 4, and then times the quantity square root of x plus 5 plus 3. Now when we simplify the numerator, first of all, you don't want to multiply out the denominator. You want to leave it in factored form so it's easy to cancel. Particularly we want to cancel that x minus 4 factor because that's what's making the denominator turn out to be 0 and make this limit not able to be evaluated. So when we simplify the numerator, we get that x minus 4, and that's over x minus 4, again, times the quantity square root of x plus 5 plus 3. Now we cancel the factors, x minus 4 factor in the numerator and denominator, and I could rewrite, have the limit as x approaches 4 of 1 over square root of x plus 5 plus 3. At this point we can do the direct substitution method. We plug in x equals 4, and then the denominator will get square root of 9, which is 3, plus 3, which is 6. And so the final answer is 1/6. Alright, number 57. We have the limit as x approaches 0 of square root of x plus 5 minus the square root of 5 over x. Again, direct substitution doesn't work. Factoring doesn't work. We see the radical expression, so we're going to multiply by the conjugate. And that would be top and bottom by square root of x plus 5 plus 5. The numerator is a difference of squares, so that's first term squared minus second term squared. So that would be x plus 5 and then minus 5 all over x times the quantity square root of x plus 5 plus the square root of 5. And in that radical and that conjugate expression above, I didn't square root the last 5. I need to do that. Sorry about that. Alright, so we have x plus 5 minus 5, which just comes out to be x, over x times the quantity square root of x plus 5 plus the square root of 5. And we could rewrite, or at this point, well, first of all, we're going to cancel those x's. And so we would have the limit as x approaches 0 of 1 over the square root of x plus 5 plus 5, square root of 5, sorry. And we can plug in x equals 0 now. We're simply going to get 1 over 2 times the square root of 5. In problem 59, we're going to use just simple fraction simplifying. We have the limit as x approaches 0, 1 over x plus 4 minus 1/4 divided by x. And you'll see that direct substitution, factor, and cancel, rationalizing don't work here. But if we multiply top and bottom by the least common denominator of that fraction expression in the numerator, which would be 4 times x plus 4, we end up with, in the numerator, just 4 minus the quantity x plus 4 over 4x times x plus 4, leaving us with negative x in the numerator, 4x times x plus 4 in the denominator. Canceling the x's and plugging in 0, we now get negative 1 over 16. And so that illustrates another strategy we can use to evaluate limits algebraically.